All right, so let's do our first example for independent samples. A study is done by a community group in 2 neighboring colleges to determine which graduates students with more math classes. College A samples 11 graduates. Their average is 4 math courses with a standard deviation of 1.5. College B sample graduates 9 graduates, and their average math class is 3.5 with a standard deviation of 1 math class. The community believes that a student who graduates from College A takes more math classes on average. Both populations have a normal distribution. Test the 1% level of significance and answer the following questions. Okay, before we go there, I've got College A and I've got College B. So I've got 2 samples. So I know College A has a sample size of 11 and College B has a sample size of 9. And I'm using a 1% level of significance. And they believe that College A graduates take more math classes than College B. All right, so here's all the things that we're going to do. This looks really similar to what we did with one mean t-test. So I want to know, is this test a 1 mean or a 2 proportion? I'm going to tell you now, it's 1 mean because they're looking at the average number of courses people took. Are the population standard deviations known or unknown? We didn't have any. All we had were the sample standard deviations. So the population standard deviations are unknown, so we can do an independent 2 mean t-test. What distribution are you going to perform on this test? Well, because I'm going to keep going. Because I didn't know my population standard deviation, I'm going to do a student t-test. Right. What are the null and alternative hypotheses? Okay, remember it said that they believe that College A has more math classes than College B. All right, for this one, I'm using College A as sample 1 and College B as sample 2. Why? Because remember I told you, when you do the sample, when the sample is definitely being talked about, let that be your first sample. So that's what I did with College A. So my null hypothesis is the mean of College A number of math courses is less than or equal to the mean average of, the average math courses taken by College B students. What's the alternative? The average number of math courses taken by College A is greater than the average number of math classes taken at College B. Is this a right-tailed, left-tailed, or two-tailed? This is a right-tailed since the alternative has a greater than symbol. And what's the p-value? Well, I'm going to use Minitab. It's going to make my life easier. So again, I'm going to go back and give you a quick rundown. Remember, these are the statistics I'm using. For sample 1, which was College A, sample size was 11, sample mean was 4, sample standard deviation was 1.5. For sample 2, the sample size was 9, the sample mean was 3.5, and the standard deviation was 1. So let's go ahead, and again, I have the directions for you here, but I'm going to show you how I'm going to do it in Minitab. So I'm going to go back to Minitab. So you're going to go to Stat, Basic Statistics, Choose Sample t-test. So I'm going to choose Summarize Data. And I already have everything in here. And remember, you can look at the PowerPoint and see what I did. Okay. All right. So I have that. I'm going to do Options. Okay. This was 99. Remember, because it was only 1%. All right. Hypothesize different. Always keep that 0. And let me show you where I'm pulling this from. I have what you need to put here. Okay. Always put the hypothesize difference, as 0. And then remember, this was greater than, so I'm going to do it as greater than. And you want to check assume equal variances. Just always do that. It will make it easier, and I'll show you why in a few minutes. Okay, hit OK. Hit OK. And look, I have everything I need for this problem. So I'm given the descriptive statistics for each. I'm given the estimation for the difference. We're going to come back to this. This is really important, and we'll talk about it in a minute. Test, we're doing my null and alternative. I get my t-value, I get my degrees of freedom, and I get my p-value. All right, so let's keep going. All right, so I have all my output, which is great. But remember, my last question was, what was my p-value? So my p-value was 0.202. The next part, do you reject or not reject the null hypothesis? Since 0.202 is less than or equal to 0.1, and that's not a true statement, we fail to reject the null. So in other words, 0.202 is greater than 0.01. And if I add that other 0, you can see why. 202 is greater than 10. So I'm going to put is true. So fail to reject the null. Okay? So you still got to, that's the way to think about it. Okay. So this is my conclusion. At the 1% level of significance from the sample data, there is not sufficient evidence to conclude that a student who graduates from College A has taken more math classes on average than the student who graduates from College B. And how do I know that? Because I failed to reject my null. And if I go back to my original hypotheses, so if I fail to reject my null, I'm keeping my null, which means, remember, the average number of math classes for sample 1 is less than or equal to the average number of math classes for College 2. All right, so that's how I did that one. So I finished it and I did everything I needed, but there's another step for this. I'm going to go into it in the next video.